So, Unit 12. Unit 12 is basically the first 2 units, or I guess all of it, that we have learned thus far has been about proportions. So, dealing with p hat, p, all of that. Now we're going to transition into talking about inference with means. So, anytime it asks you to find the average, you're no longer just going to have decimals as answers. You'll have numbers that are bigger than 1. So I want us to get a little practice with typing data into our calculator. So go ahead and get your calculators out. And we're going to put all of these numbers into list 1. So it's only one list, even though it's 2 rows. One list. So go ahead and type these into your calculator. So we're going to talk about the sampling distribution. Remember that if someone could give me a definition of sampling distribution, what would that be?
I would try the distribution of the proportion of a certain event happening.
Kind of.
How far away something is from the median?
It's the combination of, so if my population is 20, going to choose a sample size, like 3, and it would be the combination of all 3, of every possible combination of 3 fish, over and over and over and over. And then finding the means and the standard deviations of those. So what that, essentially, like if I were to put that into my own words, what a sampling distribution is, it's like taking samples over and over and over and over from a population, and then combining those averages. Just like repeatedly taking samples over and over and over and over, finding the average of those, finding the standard deviation. So if I just caught 3 of the fish, it's a statistic. No, you shouldn't have gotten this yet. This is just catching 3. So taking a sample from that, it's just kind of going over the symbols. Taking a sample of those 3 fish, I got 7.27. Took another sample, took a third sample. What do you notice about all 3 samples? They're different. And they're different because they're 3, every time I take a sample, I'm getting 3 different fish. However, what a sampling distribution would mean would be every possible combo of 3. So if I kept doing this over and over and over and over, there would be tons of combinations. If I found that average, like if I averaged all of the means together and all of the standard deviations, that would be what you got in your calculator. So you should get 8. Is that what you?
I got 8.
You should get 8.
I got 8.
Check your frequency list.
I got 8 too.
Wait, 8 for what?
I got 8.
You should get 8.
Is there supposed to be a mu? Because there's no mu on that.
No, it's just supposed to say X bar.
Do we only have 1 quiz and 1 test left?
Mm-hmm.
Is that right? 1 quiz and 1 test.
This is from Algebra 2.
But does that also apply to us?
Yes. So the reason why we got different things when we took samples is because of what we call sampling variability. So there are 1,140 different possible combinations. Remember, finding the average of all of those and the standard deviation of all of those is called a sampling distribution. So this definition, I know we've talked about it before, but it comes back up, and it comes up throughout the whole entire semester. So if we talk about something for a whole semester, I'm pretty sure it's going to show up on the AP exam. So you do need to understand what a sampling distribution is. I know that it is a concept that's difficult, especially to kind of wrap your brain around, but think about, you've got a population. You choose a sample size from that population, and it's taking every possible sample of that sample size. So in this case, my population was 20. The reason why I make the population small is just so that you can wrap your brain around it. I'm going to choose a sample size of 3. So that's what I did in the example. I had 20 fish. My sample size was 3. And when I did 20 choose 3, I got 1140. So what that means is there are 1140 combinations of 3 fish. That'd be like here, if I had 20 of you guys in my room, in my class, and I'm choosing 3 of you at a time, there's 1,140 different combinations of 3 people. Yeah, so I could put you in,
That's crazy.
yeah,
Wait, does that take into account order or which one?
no, order.
Order doesn't matter.
No, it means that there are 1,140 different ways that I could make groups of 3.
Let's try it out. I don't think so.
Yes.
Why are you teaching me?
I believe that.
They take the entire class.
And so once you do that, so let's say that I listed out all 1,140 combinations. I'm listing them all out, and I'm finding a mean and a standard deviation of your test grade. So the last test, not sigma, but S. So I'm finding all of my means and my standard deviation.
Thank you.
I don't know when it stopped recording, but it stopped recording at some time. So I don't know if it got any of that. But
Do it in 4th.
this is 4th.
Do it in third.
No.
4th of the day.
So if we were to keep doing, I skipped a few slides because I'm confident that you're able to find the mean and the standard deviation typing in data.
How confident? What percent?
I'm 100% confident that you can type data into a list.
You can never be 100% confident.
Something that you noticed.
Never accept the hoe.
Something that you will notice is that the mean of all of your samples equals mu. And that's kind of like the sampling distribution. It's just like how mu of p hat equals p. This is the same thing, but now we're just calling it mu. So this is what we learned in the last unit. Or with the 2 sample, the mu of p hat was what? With the 2 sample? P1 minus P2. That's what we've learned so far. And another concept is that when the sample size increases, standard deviation decreases because variation decreases. So star that. Something new that you'll see on several multiple choice questions is talking about which estimate would be the most unbiased. So this is a new kind of vocab term that we're looking at. Unbiased means that the sampling distribution is equal to the true value. So all you're really looking for, instead of writing all of this out, all you're really looking for is your distribution centered at the mean? And so you're just looking for that center. If it's skewed left, skewed right, something like that, then that would be biased. You want it centered at the mean. So you'll see examples on multiple choice where it'll give you like 4 different distributions, and it'll say which distribution is the most unbiased. So you're looking for the one that is centered at the mean. The judgmental sample, so the one that you chose yourself, were centered too high and were biased, while the randomly selected samples were centered over the mean. So randomization caused that center to be over the mean.
I don't even remember what we did.
Okay, the second formula, yes, is, this is on your formula chart. Yay. This one is on the formula chart.
Yay.
So the mean is mu. That one is easy to remember. In the last unit, p hat was, anyone remember?
Square root of PC.
P minus p over n.
What you were talking
Now we're taking the sigma that is given and putting it over the square root of n. This is on formula chart.
I feel formula charts where we're doing them the worst because it means
Formula
you
chart,
You have to
doesn't
figure out
make
which one it
Well,
is.
no, they can make the test so much harder if they just say they have formula charts, even if they don't give you the ones that are hard. Seriously.
I wonder if my test is right.
It's not the reason.
The less than 10% of the population is still a rule. Here we have the paper mean platelet volume in patients with metabolic syndrome and its relationship with the coronary artery
The
disease.
coronary artery sends blood to the myocardium in the heart.
Ooh.
In case you knew.
Right.
I want you to have surgery on me. I feel like
Did you get that on
I did. So, anyway, the mean is 8.25, standard deviation is
Yeah, we are.
0.75,
Oh, yeah.
and this is the volume of patients.
I think the paper titles.
Platelet volume.
That's a lot of platelet
I mean, the
volume.
platelet
Yes, I don't know what it's measured in, but it's
Yeah,
fine.
what is that measure?
This is the population data. So right here, this is population data.
8.25 what?
Meters.
Liters.
Millimeters, sorry. Not meters, that would be huge.
4 centimeters cubed.
Millimeters. Then we're going to take samples. So we're going to do this over and over and over. Here are sample sizes of 5, 10, 20, and 30.
Oh, the more samples you get, the less standard deviation.
The more samples, the higher your sample size. Higher the sample size, the smaller your what? Standard deviation.
I wrote that on my chart.
Okay.
What do you notice about the shape?
They're normal.
They're not all normal, but they're all
Dull.
They're colored.
they're symmetrical.
Oh, not.
So we can't say that they're normal by just looking at it, but we can say that they're what shape?
Bell shaped.
They're bell-shaped or approximately symmetrical. So I'm going to show you how we tell whether it's normal or not, like what to look for. So in the last unit, we had to check the equations, the NP N1 minus P. We had to do that. If you had 2 samples, you had to do it 4 times. I think you're going to enjoy this unit a little more.
8
It didn't. I don't think.
So when the population distribution is normal, the sampling distribution is also normal. So one way to tell whether it's normal or not is that it's given to you. And this hardly ever happens, but sometimes it does. And then you feel blessed.
Would it be normal if
So if pop is normal, then sampling distribution is normal. So that's when it's given to you.
That's not gonna happen.
It doesn't normally happen, but sometimes it doesn't normally happen.
That'd be the life, right?
It would be the life. Sometimes God blesses you and he gives you that, but sometimes he does not. So no matter, like if the population is normal, you could have a sample size of 2 and it would still, your sampling distribution would still be normal. Because the population itself is normal.
Are these the assumptions, or is this not a write-up unit?
This is a write-up unit, but we haven't gotten to the assumptions yet.
So these are just rules to know.
Let's see.
Wait, what?
But if your population is skewed, so for instance, this is a heavily skewed, positively skewed population distribution.
Very right.
And the prompt here, I guess the paper, the article, is the overtime period in an NHL game long enough?
No, it's not.
So they measured the time for the start of the game to the first goal scored for all 281 regular season games. They found that the average was 13 minutes and then the median was 10.
Yeah, I'd say so.
So that means that it was a positive skew.
Where's density?
Would that be
Like the relative frequency.
what-
However, when we started taking samples, so we created sampling distributions using 5, 10, 20, and 30, what do you notice is happening?
It's getting skinnier.
It's becoming more symmetrical.
And the standard deviation is getting smaller.
A standard deviation is getting smaller.
Yes, ma'am.
So there is a magic number that tells me when it becomes normal or not. This is not 10. Out of these, which one looks like the most? There is 30.
Why the 30?
Why the 30? Good question.
Why the
Why
30?
not like 31? Or like
Why the 30? I can send you a lengthy YouTube video about it.
Every time, like, oh, I'll send you.
You've never
real
sent us the
proof.
proof.
I did. Why the 12?
Oh yeah, that did.
What
happen.
was 12?
The standard deviation of a norm or
Oh my
of
god. Stop.
of a uniform, right?
Was
Like-
always
If that was in the
No.
first semester.
So we
don't know
divided
that.
something by 12.
I don't.
I
yeah,
totally
the
missed
standard
that.
deviation of one of those.
It was a uniform distribution
Yeah.
standard
It impacted
deviation.
him so.
It's been a while. Yeah, that's.
It changed my life.
Those were
It did.
That 12 saved my soul.
Okay, so when we call this the central limit theorem, the central limit theorem says that when your sample size is 30, we can assume the sampling distribution is normal. So all you have to do on a write-up is say by the CLT, we know as an AP grader what you're talking about, by the CLT sampling distribution
That means it's normal?
is approximately normal. By the CLT. There's several memes out there that are like, how did we live life without the CLT? So what you need to know for the first thing that we know is if population is normal, sampling distribution is normal. Doesn't matter what the sample size is. The second thing we can check is if the sample size is greater than or equal to 30, then we're good. We're golden. You say by the CLT, sampling distribution is approximately normal. It is sufficiently large. Here we have an example. So it says soft drink bottler claims that on average cans contain 12 ounces of soda. Suppose that X is normally distributed. So this is which one?
First one.
No, not the CLT.
Population.
No, the population.
It's that its population is so that it's given to us because it says 16 cans are randomly selected. So my sample size isn't big enough, but it's given to me that the population is normal, so I'm okay. And it wants me to describe the sampling distribution of X bar. So that's the question that it's giving me. So when it says describe sampling distribution,
Go to the library. Okay.
so when you describe the sampling distribution, you want to give the mean of X bar. So the last one was mean of P hat. This is mean of X bar is equal to what? 12. The standard deviation is, the formula is sigma over square root of n. So 0.16 divided by the square root of 16. So 0.16 divided by 4, I don't know what that is, 0.04. And then we say normal because population is normal. It's going to say normally distributed, but just normal is fine. So because it's given that the population is normal. Okay, then it says what is the probability that the sample mean is between 11.96 and 12.08? What do we do?
Yeah.
Yes. So normal CDF of 11.96, 12.08, then what? 12.
12 and 0.04.
Good.
Oh my God.
So you should get 0.8186. Remember, I got 4 decimal places.
Oh, sorry. I said
Oh, look at that boy chilling.
Okay, next example. A hot dog manufacturer asserts that one of its brands of hot dogs has an average fat content of 18 grams per hot dog
Right.
with a standard deviation of 1.
Hot dog.
Consumers of this brand would probably not be disturbed if the mean was less than 18, but would be unhappy if it exceeded 18. An independent testing organization is asked to analyze a random sample of 36 hot dogs. Suppose the resulting sample mean is 18.4. Does this result suggest that the claim is incorrect? So, without doing a full hypothesis test, not yet, we're just going to find the probability of, we're going to find the probability of 18.4 or something more extreme than that.
Could you do normal?
So the first thing we want to do is
Standard deviation.
mean, standard deviation, decide if it's normal or not. So mean is what? Standard deviation is 1 over
Square root.
30, which is just 1/6. And is it normal?
Yeah.
Yes. By the CLT, which means that n is greater than or equal to 30. The sampling distribution is approximately normal. So, then I want to find the probability of getting something more extreme than 18.4. So 18.4 to infinity, using my mean and standard deviation, and I get 0.0082.
Wait, I got 8.
Maybe you
When
did.
you return the complaint.
So interpret this value. What does that mean? What does that number mean? Like if you were to write a sentence about that
You have to put
number.
it in context. So there is a 0.00, or there is a
Chance.
0.0082 chance that the manufacturers claim that consumers would be unhappy if it exceeded 18 grams is incorrect.
Perfect. So basically, or that it is correct.
That is correct. Yeah.
So what it's saying is this value is a probability. So the chance of that happening, there's like a 0.82, like less than 1% chance that I'm going to get 18.4 as a mean value of a hot dog. Sounds silly as an example. So basically the chance of that happening is less than 1%. So if I set exceeding 18.4, then that would be the sample mean of 18.4 is large enough to cause us to doubt that the manufacturer's claim is correct. Well, that's when we would get to like a p-value and an alpha and all of that.
So every percentage is large enough.
Right.
They have to test it.